Hello, welcome to the channel. Here we go. AQA GCSE Mathematics Foundation Tier Paper 2 June 18. So calculator, let's have a go, see what we can make of this one. Alright, let's move up. Oh, here's the first question. Circle the expression that can be written as 2y. Oh, y plus y. Circle the decimal that is greater than 3/10 and less than 2/5. Well, 3/10 is 0.3 and 2/5 is 1/5 is 0.4. So we've got something in between greater than 0.3 and less than 0.4. It's going to be this one here. What is 625 as a power of 5? So 5 times 5 is 25, times 5 is 125, times 5 is 625. So it's 5 to the 4. Ooh. Circle the order of rotational symmetry in this drawing. So we've got all these little spikes going around, so every time it turns around a little bit, so it will be the same. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. Work out the value of 3 to the 6 minus the square root of 841. So now we get the calculator out on question 5. So 3 to the power of 6 minus, oh no, go back. 3 to the power of 6, that's 729. I'm going to do it in a little bit. So 729 minus, let's cancel that and do the square root of 841. 841 is 29. So that comes out as 700. Nice round numbers. Thank you very much. Don't forget, subscribe to the channel. It's very important. Gemma has 4 groups of friends. Ooh, lucky Gemma. Right. On a social media site. So she's got family, netball, schools and guides. Which group is the mode? The mode is the most common, which is school. And I'll put 26 there just in case I want to be funny. Now, Gemma wants a pictogram to show the information she has drawn. The first 2 rows, family and friends. Okay, so let's see what's some numbers. So family and friends, there's 8. So each one of these represents 4 friends. So we've got to complete. Yeah, so 4, 8, 12, 16, 20, 24, and I've got a quarter of one left over for that. And 4, 8, 9, 10, 11. I've got 3 quarters there. 3 quarters there. Looks alright, doesn't it? Nice and neat. Looks alright. Is that right? Let's do that again, because that's an even number, isn't it? 4, 8, 12, 16, 20, 24, 25, 26. So that's going to be a half. Half. Oh, come on. Erase. It's not a quarter, it's a half, because it's an even number. Well spotted for that one. Let's have a half. Sort of a half, anyway. You get the idea. Wow. E is 3 more than D, and F is 5 less than D. Write an expression for E in terms of D. So it's E is 3 more than D. Alright, hang on. Let's put the E in afterwards. Let's put the E in afterwards. So we're going to have E is 3 more than D, so that would be D plus 3. want to look at that. Or F is 5 less than D. What? Well, I don't know. 3 plus D the other way around. I don't know what the F... Oh no, here's the F. Write an expression for F in terms of D. So F is less than D, so this is going to be D minus 5. That's got to be round that way. Now work out E minus F. Well, this is E, and this is F. So we've got D plus 3 minus D minus 5. So is that going to be right? Is that going to be right? So D take away D is nothing, and 3 take away 5 is no. D minus F. F in terms of D. F is less than D. Yeah? So D 3 minus 3 minus D. I suppose what we should have done is, if we do that, put those in brackets, then that would make a bit more sense, because I've got something going on wrong here. So I've got, expand the brackets, D plus 3 minus D, and then that sign changes to 5. So DD is nothing, and 3 and 5 is 8. So brackets, millions of people would have put minus 2 in that one. I nearly did. Right, here we go. We've got numbers 1 to 12 are put in a grid. 2, 4, 5, 7, 10 and 12 are shown, yeah? Each of the 4 sides must add up to 26. Complete the grid using, right, so this is the first one to find. So 12, 16, 23, so that's 23. So to add up to 26, I must add another 3 there, yeah? And what we've got, 15, you've got 18. So 18 from 26 is 8. So 3 and 8 are gone. 3 and 8 are gone. Too many gaps now. What about 9 and 11? 9 and 11. But gamble, put 9 there. So that's 19. Remember, we're looking for a magic 26. 19. So we need another 7. Oh, we can do 1 and 6. 6 and 1 there, 1 and 6. So that must be 11. Does that work? 7, 18, 19, 20, 21. 21 with 5 short. So these are the wrong way around. So 1 and 6 are the wrong way round. So that must be, oh, I don't like this one. 6 and 1. So 19, 20, 26 going down that way. 18, 19, 20, 26 going that way. So that's right. Yeah, awkward little one, that. In this question, use 1 foot equals 12 inches, 1 inch is 2.5. Change 5 feet, 8 inches to centimetres. Well, 5 times 12 is 60. And then you've got 60 plus the 8 inches, which equals 68. So now you do 68 times 2.5 will give you how many centimetres? So 2.5 is 170. 100, not a point, 170. Which of these numbers has exactly 4 factors? So this one, 1 and 4 and 2 times 2. 8. 1 and 8. 2 times 4. Yeah, that looks like that one. How about this? 1 and 12. 2 and 6. 3 and 4. So that's too many. So it's going to be 8. No point doing 16 because that would be even more, wouldn't it? So what are we doing with it? The next question. Oh, Nick has a 6-digit code. He remembers it as 3 2-digit numbers. The first number is between 10 and 20. The second number is 3 times the first number. And the third number is 5 times the first number. All 6 digits are 12. Different. So I was just thinking of 12 could be the first pair. And then the second pair is 3 times that. So that could be 36. And the third number is 5 times that. 5 times 30. Oh, 5 times the first number. 5 12 is 60. Oh, that doesn't work, does it? Can't be 13 because that would be then 39. 14. 3 14s are 42. No, that's not wrong. 15. 3 15s are 45. And 5 15s are 75. 75. No, that doesn't work. 16. 3 16s are 48. And 5 16s are 80. No, that doesn't work. 17. 3 17s are 51. No, that doesn't work. 18. 3 18s are 54. And 5 18s are 90. Yeah, so that's it. So we've got 18, 54, and 90. That's it. Whoa, would be the last one we thought of, wouldn't it? How many minutes are there in 5 1/4 hours? Well, 5 times 60 is 5 6 is 300, and 1/4 of an hour is 15, so that's 315. Here's a formula for the amount of water needed to cook rice. W is the number of cups of water needed, and R is the number of cups of rice to be cooked. How many cups of water needed to cook 7 cups of rice? So the water equals 1.5 times 7 plus 0.5. So 1.5 times 7 is 10.5 plus 0.5 is 11. How many cups of rice can be cooked with 20 cups of water? So 20 equals 1.5 R plus 0.5. So take away 0.5, which gives me 19.5 equals 1.5 R. Divide by 1.5. 19.5 divided by 1.5 equals R, which equals 19.5 divided by 1.5 equals 13. 13. And that was, oh, the answer to number 13 was number 13. Oh, love that. Now we've gone on to the next one. Number 14, I would guess, is the next question. Okay, let's have a look to see how we're going with the levels of the volume and things. Yep, that's fine. Right, use the calculator to work out that. Give it, okay, so 9.95 squared times 29.8. There's no need to put your working down, you just put your answer. 22950.2745. Is your answer to part A sensible? Use approximations. Well, I'm going to go 10 squared times 30. 10 squared is 100 times 30 equals 3,000, 2,900. Yeah. So it's sensible. Is anybody going to put not sensible? I really don't think so. Because if it isn't sensible, you don't know, do you? Because you don't know it's wrong. That's stupid. You actually get a point for ticking sensible. That's the best point you're ever going to get in a GCSE. Right, what we're doing now. The graph of x equals 4 minus y from the values of -2 to 5 as shown on the grid. Draw the graph of y equals 2x minus 5 from the values of x equals blah 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 blah. Okay, so let's do this x and y. It's a straight line graph, yeah. 1, 2, 3. If you get 3 in a straight line, you're okay. So put the 1 in there. 2 times 1 is 2, minus 5 is minus 3. Put 2 in there. 2 times 2 is 4, minus 5 is minus 1. 2 times 3 is 6, minus 5 is 1. So I've got 3 points there. X is 1 and y is minus 3. X is 2 and y is minus 1. X is 3 and y is 1. So I've got 3 in a row. And we've got to draw it to 5. So I'm going to do my best this. I would do this with a straight line there. With a ruler, sorry. And where we're going to -2. So we're going to... There. Okay. So that is my... y equals 2x minus 5. Right, so now, come on, Dad, come on. What we're doing is use your graph to solve 2x minus y, that, equals 4 minus x, that. So it's when the y value is the same, which is the y value is 1 or the x value is 3. We're solving x, aren't we? Solving x. We don't care about y. There's 3 where they cross. There. Oh, thank you. X equals 3. I was confused. Never mind. Oh, what's going on here? BCD is a straight line. Triangle ABC is equilateral. ABC. That means that's 60. Yeah? What are we doing? Work out the size of x. Now, isosceles triangle. So 180 take away 28 is 152. Right? So you get the 152. Divide that by 2. 152 divided by 2, should be able to do that in my head, equals 76. So that's 76 and that's 76. Now we've got to find x. These 3 are on a straight line. So 180 minus 60 and 70 is 130, which equals 50. So x equals 50 degrees. 50 degrees in the shade. Oh. They've got 44 there. What have I done? Can't count, can I? Can't count. Oh look, that's 76. It's just my bad drawing there. 76. See, if I was neater, it's not 130, is it? Stupid person. Stupid person. So, right. So 60 and 76 is 136, which is 44. Amber is working out the size of an interior angle of a regular octagon. Interior angle is 360 divided by 8. No, it's the exterior angle is 3. No, the good reason the exterior angle is 360 divided by 8. Yeah, completely wrong. Have we got to actually say what it is? Okay. 360 divided by 8 is 45. Exterior angle is 45. So the interior is going to be 180 minus 45, which equals 155. Right. Oh, here's a map. Right. A is due west of B. Write down the bearing of A from B. Of A from B. So there's north. A from B. So it's round there. So that's 270 degrees. Okay, 270. All the way around the corner. Now what we've got to do, 17B is going to ask us about something else, isn't it? Umar drives from A to B on the route shown. Kaz drives from B to C on the route shown. Use the map to work out how much farther Umar drives than Kaz. So A to B and B to C. I really can't really measure this, but if you imagine that I could, and I've measured A to B as, say, A to B as 7 centimetres. I'm going to do the answer here, yeah? So A to B, I've got 7 centimetres, and 1 centimetre represents 2 kilometres. So if I multiply that by 200, I will get 7 times 200 is 1,400 kilometres. Are you serious? You're driving 1,400 kilometres? Yeah? Wow. And the other one drives from B to C, don't they? B to C. Now, I'm going to measure that as well, so bear with me. I reckon that's about 3, and that's about 2. So we'll call that B to, where's my, there. B to C, I'll call that 5 centimetres times 200, and that's 1,000 kilometres. And the difference is just one take away the other, which is 400 kilometres. I can't see how this is so big. It just seems such a long way to drive, doesn't it? Yeah. Now you will be allowed a little bit here and there, depending on how good your measurements is. But that does seem a long way to drive. That's like, ugh. A shop sells raincoats and umbrellas. Brilliant. The scatter graph shows the monthly sales for 12 months. Write down the type of correlation show that, well, it's a positive. Now, the manager expects a sales umbrella next month to be £60. Draw a line of best fit to estimate the sale of raincoats next month. So there's £60 there. That's umbrella. So best line of fit is just going to be something that goes up like that. Yeah, maybe. And so we've got up to there to get to the best line of fit and go along there, and that's about 105, 10, 15, maybe about 120, maybe about 120 pounds. And so around about 120. Let's have some better questions than this. So multiply out. So that is x squared minus 4x. There. Yeah. 8 to B is 5 to do. How many times larger is A than B? A to B is 5 to do. It's 2.5 times, isn't it? 2.5. 2.5. 2.5 times larger. A circle has a radius of 4.2. Work out the length of the circumference. So circumference is pi d. Circumference equals pi d. So that equals pi times radius diameter 8.4. So pi times 8.4 is 26.38. Oh, so I'm going to do 26.38, 9 and all the rest of it, yeah? But they want the answer to one decimal place, so it's going to be 26.4. The circle below has a centre O. Draw a sector on the circle. The sector is like this. That's a sector. Anywhere, any size will do. 2 ordinary fair dice are rolled. Complete the tree diagram. So you've got a third less than 3. So it's 1 out of 3. Ooh. Less than 3. Oh yeah, because it's 2 out of 6, isn't it? So how many more? We've got 3, 4, 5 and 6. So that would be 4 out of 6. So we go for 2 out of 3. Right, so, okay, 2 out of 3, 1 out of 3, and 2 out of 3. Work out the probability that both dice land on a number less than 3. Less than 3, less than 3, so we're going up there. So we've got a third times a third, which equals a ninth. A ninth, and that was 22. Right. A ninth. Oh, sequences. Right. So a geometric thing is when we're multiplying by something. Look, 1 times 2 times 2 times 2 times 2 times 2. So that's a geometric when we're multiplying. Yeah, multiplying by 2 there. Arithmetic is when we're adding something. So with this 1 plus 1 plus 1 plus 1. So this is an arithmetic there. So we'll just add in the 1 there. Square numbers, cube numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So that's the square numbers. So 2 cubed, 3 cubed, that's cube numbers. And this one must be triangular numbers. The table below shows information about a population of a city. Population 2001, population 2011. Liam claims from 2011 to 2021 the population of the city will increase by the same percentage. He works out the population increase from there to there is 60,000, and then the population there, so he added another 60,000. Does it match its claim? No, because it didn't use the same percentage. So we're going to work out the percentage population. So the difference over the original times 100. Yeah. So with the first one, the difference between that is 60,000. So we're going to do 60,000 divided by the original 420,000 and times that by 100. So 60, 123 divided by 42, 123 equals, times it by 100 is 14.28%. So I'm going to say 14.28%. So that's the first one. So the next number here, if we go 480,000, and I'm going to times that by 14.2%. So 14.28 over 100. Find out what that is. So 480,000 times 14.28 divided by 100. So that equals 68544. Add these two numbers together and that shall give you the new population, providing they're going up at 14.2%. So I add onto that one 480,000, and that gives me 548,544. 548,544. And they thought it was going to be that, so this is why. No. Lots of different ways to do that. 548. Yeah. Okay. Number 25. Number 25, good. I'm alright with number 25. No idea. What are we doing? On 3 days, all Ali throws darts at a target. Here are the results. Work out two different estimates for the probability of Ali hitting a target. Right. So we could take all the number of throws, which is estimate number 1, yeah. We could do, he'd hit 54 out of 90, yeah. Should we make that a percentage? Yeah, okay. So we could do 54 divided by 90 times 100 is 60%. So that's 60%. Now what else could we do? We could do these three individually, but that would just give the let's see, 15. We could do these three individually, so that would give us 15 over 20, 22 over 30, and 17 over 40. Yeah, I think this is a stupid way actually, but they want another way, and they're only giving us a couple of marks. Yeah, so 15 divided by 20 equals, now I did 15 divided by 20 times 100 is 75. So we got 75% on Monday, and on Tuesday it was 22 divided by 30 times 100, which is 73.3%. And on the Wednesday it was 17 divided by 40 times 100, which gives 42.5%. 42.5%. Now if I add these three together and then divide by 3, see what happens with that. Yeah, so 75 plus 73.3 plus 42.5 equals, so that all equals 190.8. Divide that by 3, and that gives me 63.6%. Yeah, equals 63.6. I'm sure there's other ways of doing that. How many throws and how many misses, and then take that away from 100 or something. Which of your two answers is a better probability? I think answer A is best. Reason. Why is answer A best? um, uh, answer A. Answer A is best because it's. Did we have to work out a percentage or could we just set a probability? Yeah, I don't know. It's just a bit crazy. I don't know whether I could have left that as 54 out of 90 for that one. Not bothered to make it a percentage, but a probability can be a percentage. I've got a 60% chance of doing something, yeah. Answer because it uses the total for the 3 days and not average of the 3 individual days. Yeah, I don't like this question. It's not really clear what you need to do, but I think I've got it. Theo starts savings of £18 and Jamie starts with nothing. Each week from now, Theo will save £4.50 and James will save £4. In how many weeks will Theo and James have savings in the ratio of 15:8? So let's do this, Theo and James. So Theo's got £4.50. So this is week 0. Yeah? Week 0. And James has got nothing. Theo will save £4.50 each week. So he's going to have £9 and £13.50. Right. So I'm just going to do about 8 weeks or something, yeah, and then we'll look at the ratios between them. So 13.50. So 13.50. We're going to plus £4.50, which is £18, plus £4.50, which is £22.50, plus £4.50, which is £27, plus £4.50, which is 31.5, plus £4.50, which is 36. Right. I won't make you go out that far. James is going to save £4, so he's going to go 4, 8, 12, 16, 20, 24, and 28. Now we're looking for this magic ratio of 15:8. 15:8. So there's 8 to 13 and a bit, so that doesn't work out. 15:8. 16 to 30. That's not enough, is it? So maybe it's Theo should have started with £18. That's why it didn't work out. Oh, Theo, I forgot your £18. This may become more obvious now. If Theo starts with 18 and he saves, then that would be £22.50. Another £4.50 on that is 27. Another £4.50 is 31.50. Another 450 on that is 36. Another 450 on that is £40 and 50. Another 450 on that is £45. Oh, look at this, yeah. So look at these numbers here. I've got 45 and 24. That's the ratio. That can be simplified to 15/8. Yeah, divide both by 3. So this is week 0. 1, 2, 3, 4, 5, 6 weeks. I know I made it. I suppose could you do that with algebra? Who knows? Probably. Right. A volume of a sphere is 4/3 pi r cubed, where r is the radius. A container holds a hemisphere of 30 centimeters. Sand fills a container. Does it take less than a quarter? So let's work out the volume of this hemisphere. Remember, that's the volume of a sphere. So we got 4/3 times pi times r. R is the radius, is 30. And I'm going to divide the whole thing by 2. So 4 divided by 3 equals times pi times 30 cubed equals, and that equals 113097.3355 centimeters cubed. So that's how big that thing is, yeah? Now we're going to fill it up with 4,000 a minute. So if we take the 113097.3355 and divide it by 4,000, this is going to tell it divided by 4,000. That's 28. 28. 28 minutes. That seems a bit. That seems. They're looking for a quarter of an hour, so they're looking for closer to that. That comes out as 28. I don't think that's right. I'm going to do this again. Yeah. Did I divide by 2? I don't think I did. I forgot to divide by 2. That's where I went wrong. Right. So, 113097.3355 divide by 2. So 3097.3355 divided by 2. 113097.3355. Why have I got all those dots in there? 113097.3355 divided by 2. Right, so that comes out as a 5654.8.67. Oh, got fed up with all the decimal points now. So now we take that number, 5654.8.67, and divide that one by the 4,000. Yes, and divide that by 4,000. That equals 14.137 minutes. So less than a quarter of an hour. Does it take less than a quarter of an hour? Yes, it does. Oh, forgot to divide by 2. Bonkers. The length of each side of a regular pentagon is 8.4 to 1 decimal place. So we're going to look at 0.05 is the error interval. So we're going to go up to 8.45 and down to 8.35. Okay. Then we've got the length of a regular pentagon. So now if we can multiply this by 5, so 8.35 times 5 is the smallest. 8.35 times 5 is 41.75. So that's 41.75, and this is 8.45 times 5. So 8.45 times 5 is 42.25. 42.25. Okay, end. So nearly forgot to divide by 2. That one is a stupid question. Didn't really get what they were trying to do there. Probably that was okay. That was okay. Okay. Sure, there was something else that was okay. Yeah, this driving from, this was drive 1,400 kilometers. Yeah, who does that? Go on a plane. It's too far. Yeah, that was okay. Pretty much everything apart from that silly darts average probability type thing. Yeah, I'm happy with that. Okay, good. I hope you enjoyed that one. Yeah, it took a little bit longer, that one. Now, do not forget, subscribe to the channel and help it grow. Make a comment. Ask me to do anything you like. Put your thumbs up to say you've watched it. And down below there's more of these videos to watch. So I'll see you in the next one. Thanks for watching.